Welcome to Sydney CocoaHeads, October 2020, continuing the COVID edition tradition. I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land that I'm presenting from, and pay my respects to the elders, both past and present. First up, some housekeeping. Hi, I'm Carl, and a big hi from Zach and Nikki, who work tirelessly to help make CocoaHeads happen every month. If you have any questions, you can reach us on Slack or Twitter. Thank you to our long-term sponsors, Bilue and Atlassian. We look forward to being able to host in-person events again soon, but when the time is right. Welcome to Sydney CocoaHeads, so stay tuned. October 2020, continuing the COVID edition tradition. Slack and events, online and in person. I would like to acknowledge the Gadigal people of the Eora core values are to be respectful, traditional custodians of this land that I'm presenting from. We take our responsibility seriously to the elders. If you have any issues, concerns or suggestions. First up, some housekeeping. Hi, I'm Carl, and a big hi from Zach and Nikki, who work tirelessly. Welcome to Sydney CocoaHeads, October 2020, continuing the COVID edition tradition. I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land that I'm presenting from, and pay my respects to the elders, both past and present. First up, some housekeeping. Hi, I'm Carl, and a big hi from Zach and Nikki, who work tirelessly to help make CocoaHeads happen every month. If you have any questions, you can reach us on Slack or Twitter. Thank you to our long-term sponsors, Bilue and Atlassian. We look forward to being able to host in-person events again soon, but when the time is right, so stay tuned. CocoaHeads Slack and events, online and in person, have a code of conduct. The core values are to be respectful, be inclusive, and be aware. We take our responsibilities seriously. If you have any issues, concerns, or suggestions, Zach, Nikki, and I are available anytime. Along with the presentations tonight is the Sydney CocoaHeads Slack community. Jump into the Meetup channel to follow the discussion, post any questions you have during the talks, and follow the presentation Q&A. One of my favorite parts is seeing all of the new members. So if it's your first time attending Sydney CocoaHeads, please raise your hand, have a look around, and could you please give everybody a warm welcome. It's great to see so many new faces at every event. Speaking of events, go check out our bitter rivals, Melbourne CocoaHeads. It's hosted every month on the second Thursday, packed with great talks, and recordings are also available on YouTube. AUC Everyworld is a new event this year. The AUC, who normally run DevWorld, CreateWorld, and XWorld, are combining the three events this year. It's a three-streamed conference focusing on development and frameworks, arts and education, and device management. It's taking place 25th to the 27th of November. They also have a Discord channel, and call for presenters is still open. November CocoaHeads, it's going to be the last event for the year. It's coming up quickly. We're taking a break in both December and January. So it'll be your last opportunity to present this year. Contact us on Slack or via the submission form on sydneycocoaheads.com if you'd like to be involved. Tonight's schedule. Hiring and firing. So we have 4 recruiting pitches tonight, and if you are looking for work or recruiting, head on over to the jobs channel and in Slack and post about it. Commonwealth Bank, looking for a senior iOS engineer to join one of the mobile teams at CBA. Greenfields project, amazing team, flexible work from home policy, come join us, be part of the change. Savage, developers of Procreate, encourage everyone to apply regardless of whether they think they can do it. They said, let us be the judge of that. And they're looking especially for interface developers. Relocation to Tasmania, and did I mention they're the developers of the amazing Procreate app. Bilue, from sponsoring Sydney CocoaHeads fame, are looking for Android and iOS mid and senior engineers, React Native mid, senior and leads, mobile tech lead, and AWS cloud engineer. SafetyCulture, looking for iOS and Android software engineers to work with their modern technology stack, including Swift, Kotlin, and C++. DM Enrico Sitseo in Slack, and for any information on all of these roles, jump into the jobs channel in Slack. Month in review will be up first by myself. It's going to be brief because we've got a lot to get through this month. We've got three feature-length lightning talks and a feature talk. First lightning talk is Fastlane App Store Connect API Key by Josh Holtz, followed by Widgets 101, a tiny amount of useful information by Malin. Welcome back to Sydney CocoaHeads, by the way. Map Memory Management by Zach, and Show Me, Don't Tell Me, adding demonstrations and tutorials to a SwiftUI app by David Reddy. Lastly, join us for post-meetup Zoom catch-up. The link will be posted in Slack at the end of the meetup, and please don't post the link anywhere public, like Twitter, because it will be scraped and spammed. Let's jump straight into month in review, and we're going to start with 4 app updates from Australian developers, all with widgets that have earned a permanent spot on my home screen. Petty by Zach for real-time petrol prices has added iOS 14 widgets. The screenshot on the right is now my preferred way of monitoring petrol prices. Streaks and Streaks Workout received updates with iOS 14 widgets, permanent widgets on my home screen. Relatively new entrant to TV show tracking is TV Forecast. Added iOS 14 widget support, permanent widget on my home screen. And iComics by Tim Oliver has received an iOS 14 update with widget as well, permanent widget on my home screen. With updates, macOS 11 still not released. Not fully baked, Big Sur's not fully baked yet, but we've had watchOS, iOS, and tvOS updates released. After those updates, we then had iOS and tvOS jump to a .2 beta, and watchOS jump to the .1. Given that the watch hardware had already been released, that made sense. iPhone were expecting the hardware to be released, so they were likely reserving the .1 for the hardware bump. So that kind of indicates that we could be expecting an Apple TV hardware refresh soon. In the updates, iOS 14.2 beta, we've got new emoji, such as the classic boomerang. Apple terminated Epic's Mac developer account. Epic announced Fortnite would no longer be playable on macOS. Injunctions, judges, more drama, and then it was all very early after last Cokehead, and then it's become fairly quiet since then. We'll wait to see what happens next. Out of nowhere, CheckRain 0.11.0 released, adding iOS 14 support. Amazing work from those developers. Exposure notifications, nothing to announce, still not used in COVID Safe app. Great work. Instagram celebrates its 10th birthday. They released an update with a back catalogue of previous home screen icons. UI WebView deprecation deadline has been extended again, not sure when to. There must have been a lot of pleading with Apple from some pretty big companies to extend this again, as given how many times it's already been extended. Now jumping into Apple's event this week. HomePod Mini, a new device announced at the event, $149 Australian price point, which is about where I expected it, and I think it's pretty well placed for the Australian market now. Orders starting on November the 7th. iPhone 12, 12 mini, 12 Pro, 12 Pro Max. I guess I have to mention them, especially seeing as they've got the correct edges back on the iPhones again. Great work. Out of the blue, MagSafe is back in the form of magnetic attachments for the iPhone. MagSafe charger, a MagSafe wallet, and MagSafe cases are all being released. And that brings us to the iPhone lineup in Australia. We've now got the iPhone SE, the iPhone 11, The iPhone 12 starting at $1,200 and the iPhone 12 Pros and Pro Max starting at $1,700. That's all for month in review. Let's hand it over to Josh. Take it away.
Hello everyone, I'm Josh Holtz, and today we'll be giving a lightning talk on the App Store Connect API in Fastlane. We don't want your Apple ID anymore, so I'm all about this App Store Connect API key. So, to get started, who am I? I'm Josh Holtz, as I just said, I guess. I started Rocket Cat, which is a software consulting company. I started that in 2011 with a few of my friends. We do software consulting, front end, back end, mobile. I focus on iOS, macOS there, but I'm currently actually doing Fastlane full time, which is super cool, and I'm so thankful for that. I've been a Fastlane core contributor since 2015, and I've been the lead maintainer since March of 2018. So I've been the lead maintainer. I do a lot of issue management, pull requests, new features, releases, and kind of figure out where we're taking things going forward. Um, let's get started on this. Well, I guess we'll start with what is Fastlane. Fastlane is app automation done right. Um, Fastlane helps you automate screenshots, beta deployments, building your app, code signing, app store deployment. You can pretty much automate almost any part of your mobile process. Some things require more work than others. But today, what we're going to be talking about is what Fastlane does with App Store Connect. So, App Store Connect is the place where if you're an iOS developer, macOS developer, tvOS, watchOS, you use App Store Connect to create your identifiers, certificates, profiles, register your devices for testing. You upload your app metadata, pricing, screenshots, previews. There's more on top of that too. And then there's also a tool, the command line tool that Apple provides called Transporter, which allows you to upload your apps to the App Store and list the teams that you belong to. It does more, but that's really all we use it for right now. So Fastlane does a lot with App Store Connect. App Store Connect is like the whole website that you do all of the clicking and stuff through. With Fastlane, we don't want you to click anything on App Store Connect, so everything is scripted, and Fastlane does all of that communication for you. So the way that Fastlane previously communicated with App Store Connect, or when it was also called iTunes Connect, Fastlane used the same API that the web browsers use. It was in an API that was kind of a private API that wasn't meant for how Fastlane is using it, but we still used it, and Apple allowed us to, which was fantastic. The one bad part was that this legacy API required your Apple ID to log in, which required you to use your email and password, which isn't necessarily great. Fastlane doesn't keep on to any of that. We don't store anything. Nothing leaves your machine unless you tell it to for some reason. But it wasn't necessarily secure. And you also had to select which team you wanted to use it to. Like, I belong to quite a few teams, and it becomes a disaster. And I need to make sure that I'm always kind of authed in to the right team. And then all of the Apple ID accounts now, I believe there might be a few cases there, require two-factor auth, which means that your session is only valid for, I think it's somewhere between 15 to 30 days, sometimes less. And you have to enter a code to say that, yeah, it's actually me using this, which is not great if you're doing automation, especially on a CI. Um, and you don't really want to put your personal Apple ID out there either. So we usually recommended that you create a Fastlane specific Apple ID. Um, and uh, when you were uploading an app binary, you also couldn't use your Apple ID with two-factor auth. You had to create an app-specific password, which is generated on appleid.apple.com. You would mainly use this if you were using our Deliver tool. Um, and you had to create this app-specific password under your own Apple ID, and then set that with in order to authenticate the binary upload to App Store Connect. So there was a lot of weird authentication levels that you had to go through. Um, Email password, select your team, sometimes two-factor auth, and then you also had to use this app-specific password. So we're gonna go into like what a really simple Fastlane script would be. So here, this is a release lane that we would use cert to verify that you have the certificate that you want in order to build and sign. SCI, which gets your provisioning profile. And then deliver is the tool that then uploads to App Store Connect. And in order to upload deliver, then you had to set this Fastlane Apple application specific password environment variable. And like it works, but it's not ideal because we want to use the most secure thing possible, and using your own Apple ID should not be the case. So Apple announced the App Store Connect API, an official API meant for developer usage, at WWDC 2018. I was actually sitting front row at that announcement, and I think that was probably like one of the happiest developer moments of my life. I was so excited to see this because this meant a lot more stability and security for our end users. What was announced in 2018 was just like the test flight section of the API. It was only a small portion of Fastlane, but I was still super excited for what was going to come. Fast forward to summer of this year, almost all of Fastlane, for like the majority of users, is now able to be automated with the App Store Connect API key. Sorry, with the App Store Connect API. So this is Apple's official developer API. Secure. You don't have to use your Apple ID. What you do is you generate an App Store Connect API key over at appstoreconnect.apple.com/access/API. I believe like an admin is the only one who can do it. And also currently is not enabled on enterprise accounts, but it hopefully should be. So when you create your API key, you're given a private key ID and then a private key file to download. You can only download it after the time of creation. If you refresh the page or come back, you can't create it again. So make sure you put it in some secure location, 1Password, other secure things. That's really all I know. But the three things that you're going to need to know when using it is the issuer ID, which is shown on the API page, the private key ID, which is always shown, and then the private key, which I said you download once, and you can only download it once. You can revoke it and recreate it, but you will want to make sure that you do store it in a safe place. And then the API key only works for one team. So unlike Apple ID, where my Apple ID would be attached to multiple of accounts, and I gotta select the team, this is much nicer because I know that my one API key will only work for one team, so I won't necessarily make mistakes and create a bundle ID on the wrong team. It happens sometimes. Shouldn't happen anymore. So what this looks like now with a fast file, it's a little bit different, and there's multiple ways we can do this. This is just the one example that I have. There's a new action called App Store Connect API key. You put your issuer ID, your key ID, and then the file path to the P8 file. And the tools that will access the App Store Connect API will be able to see the key information from this action and create the necessary authorization tokens to authenticate the API. So to me, this looks a lot cleaner. I mean, there was also ways to clean up my last example, but I really like this approach, and my Apple ID is no longer associated with any of these actions. So what does this change actually do? For the end user, it's not super noticeable unless you are, like I said, on a CI. You don't want to deal with 2FA. Or also if you want a little more stability, and I'm going to go with a little bit more performance. I have seen that the official App Store Connect API does do things faster. But I mean, I don't know if performance is actually one of the keys listed, or one of the benefits listed on their website. But I have seen performance increases. Sorry. So previously with the Apple ID, there was a lot of hoops to jump through. We first had to use the Apple ID to auth into idms.apple.com, store the cookie, and then some other header information. In between here, actually, if your session required 2FA, you had to get prompted with the 2FA code, enter some numbers and whatnot, and then the session is stored locally in your Fastlane directory, hidden Fastlane directory. And then there was also a bunch of different endpoints that we had to hit because the developer portal and the App Store Connect part were two separate APIs. So we had the legacy endpoints, which is what iTunes Connect had back in the day. And then now we are almost done with those legacy endpoints. And then there's a web session endpoints of the App Store Connect API. So this is a subset of App Store Connect API endpoints that only the website stuff can hit. It doesn't use a new auth. It still uses the same web session, but it's the similar response to what the official API offers. So that is what most of Fastlane uses now. We've done a lot of those changes within the past year and a half. Users shouldn't have really noticed anything, but we can still use the Apple ID with the App Store Connect-ish type of endpoints. So there was a lot of like cookies, headers, different endpoints that got hit. But now with the new official App Store Connect API, a lot of this is cleaned up. So now what it looks like is with the API key information that you provide, Fastlane will create a JSON web token, which is essentially, well, what it does some encoding of information and whatnot, but it ends up being just like a base64 encoded string that we set in an HTTP header for authorization, and then we just hit the endpoints and we call it a day. It's so much simpler. I've seen it. It's much faster too. And then when uploading with Transporter, which is the tool that Deliver uses to upload the binaries, instead of having to create that app-specific password now, Transporter actually also offers us a -JWT option, which Fastlane does for all of you. So that same authorization that you're using with that token to upload meta information, create profiles, all that, is actually used also to upload the binary. So this token is super powerful, and the token also has a duration that you can set. So by default, we set the duration to 20 minutes, which is the max length of the token. If you don't want the web token to be authorized for that long because you're on a CI doing stuff, you could limit it to 5 minutes if you want. But the default is 20 minutes. So what we're going to do now is we're going to hop into a little demo. The demo is going to show how we 1 second. All right. So the demo is going to is going to show a very simple Fastlane project that I have that will get the provisioning profile. I don't want to make it too complicated. It's currently using the web session using my Apple ID. And we're going to change it to using the App Store Connect API. Right here. And then I'll show different ways to configure it. So we're going to go over here now. All right, so this is my demo project. We'll get to this after block plate. Well, no, we'll get to this now. So what Spaceship Stats does is this is an action that will actually print out all of the API endpoints that were hit during this run. So we can actually see if it's hitting the web session API, the legacy one, the new App Store Connect one, or if it's hitting the official App Store Connect API. So this is a demo of Psy that is going to give us a provisioning profile using my username and team, which this is what I need for Apple ID. We're going to run this, maybe. Hold on. Where'd it go? There. Okay, there it goes. So let's reset here. All right. So we're going to run bundle exec Fastlane demo. And we'll see that I need to do two-factor auth. That's unfortunate. I actually set this up to happen this way. So this is because I'm using an Apple ID and I deleted my session. So we're just going to say, okay. So now it's looking for the profiles, blah, blah, blah. Okay, we'll see. We successfully got our provisioning profile downloaded. We had to do a legacy iTunes Connect auth to IDMS. We had to do another auth onto Olympus. We then did a, what does this one do? I don't know what this one actually does. This is another thing. And then here we hit the App Store Connect API web version to actually download the profile. We'll run this again and see how long this took. And okay, took 2 seconds, that's fine. All right, so now we're gonna actually create the App Store Connect API. You might see a time difference when you're doing more requests. Psy is a relatively easy tool, so we won't look at the performance here. I'm actually gonna delete one of my old auth keys. Okay, all right, cool. All right, so we're gonna go over here. This is the, let's refresh, make sure I still have access to this page. Oh, let's close some of this stuff too. All right, we're good. We're gonna create a new API key. We're gonna call this one Sydney demo. And I'm going to, let's do admin access. Okay, I'll revoke this later, it's fine. Okay, so we'll see, I got a Sydney demo. This is the key we're gonna copy, but we're also gonna download this API key. Download. Perfect. Okay. Allow. Okay. I am going to. Where can I find? Where are my downloads? All right. What is this? Okay. So we're gonna copy this key. We're gonna go over here. We're going to copy from downloads auth key. We're gonna put this in my Fastlane directory here. I'm actually in my Fastlane directory, so we're just going to put it here. Right? Yeah, I'm in my Fastlane directory. Okay. So if I ls Fastlane now, we have our new key in here, which is great. We're going to go back into our editor here. We're not going to, actually, we'll create a whole new lane. We're going to keep that lane there. Demo API key. Okay, cool. So we're going to get rid of this and this and this. We're going to call this new action App Store Connect API key. We have an issuer ID. We have a key ID. Oh, my dog is barking. Okay, we have a key ID. And then we have a key file path, which is going to be fastlane/auth key _.p8. This issuer ID, we're going to pull from up here. We're going to copy this. I put it in the wrong spot. What's going on? Oh, hold on. Did I freeze? Oh, what's going on here? I made it freeze Vim. Didn't know I could freeze Vim. That's cool. Okay, fun demo. Okay. All right, well, let's get out of here. Live demos are fun. Let's see, Project Sydney. Let's try this again. Okay. Edit anyway. Okay. Let's take 2 here. This isn't really a live demo. This is being recorded. So, demo API key. All right, let's try this again. App Store Connect API key. Issuer ID. We'll take the issuer ID first because I already have that. There we go. Okay, so that works. Key ID. The key ID is this guy. Key file path. We are going to do, what did I say? Fastlane /auth key _.p8. And then we also need to do this in-house equals false because we're using Sci. Sci will do some different stuff if you're either an App Store Connect, or sorry, an App Store account or an enterprise account. Enterprise accounts aren't a thing right now with the App Store Connect API, but we still have to set this. Hopefully this works fine. So I think this is right. We're gonna run bundle exec Fastlane demo API key, and it looks like it's working. Boom. Okay, we'll see. It only did 1 API request because it didn't have to do any authorization. It just sends up that JWT token, and that works great. So you can do it this way. Tools like Sci, Cert, Pilot, Deliver will all look. So this App Store Connect API key puts something in the lane context. So if you call this API key within the lane, other things within that lane will be able to see it. But there's other options that we can do. I like to use this this format that we created, which is a JSON format for the key, where you can provide the key ID, you can provide the issuer ID, all right, and then we can base64 encode the content in this JSON file, pass this JSON file between projects pretty easily. Everything is self-contained, which is super nice. I wish I actually knew how to base64 encode through Bash. I actually don't off the top of my head. So what we're gonna do is we're going to base60. I'm gonna do this. Nope, I want base64 encode. Yep. That's fine. Okay, whatever. There we go. Okay, so this should, now what we'll do is instead of creating the App Store Connect API key, or calling the App Store Connect API key action, we can do API key path, I think it is, and we're gonna call Fastlane /me.json. It's called me because this is my personal team. So we'll run this again. Hopefully this works. It looks like it's working. It worked again. Okay, cool. So, we can go back here. Okay, cool. So there's you can also then store all this information in environment variables too if you want. So you can set it on your CI. You go to docs.fastlane.tools, go to using App Store Connect API, and then this gives information on how to use it. Kind of what I did here. This is going to be growing more and more. It's going to be updating with all the tools that are updated. There are some actions also that use the API key now. I think that's it. If you have any questions, feel free to tweet me at Josh D. Holtz. On Twitter way too often. You can find my stuff that I do on GitHub. I think I will be on for live Q&A of some sort, maybe. But if not, tweet me. I try to always respond to everyone. Sometimes I miss, and I'm sorry, but I will try and hit you all. Thanks for the time, everyone. I had fun.
Hi, everyone. Oh, it looks like it's still set to Northern Hemisphere.
Oops, I can help with that. That looks better.
Awesome. All right. Hi, everyone. For those who don't know me, I'm Malin. I used to live in Sydney before moving to Vancouver, Canada. And I'm working on an app called Orbit together with Kai. And Orbit is a time tracking and invoicing app for macOS and iOS for freelancers and contractors. And lately we've been working on adding some widgets to the app. And I'm in general super excited about widgets, and I use them a lot on my home screen. So I want to run you through how you can add widgets to your apps. Let's get started. So a widget, for those who are not too familiar with them, a widget is an extension of your app that a user can decide to add to their home screen. They can add them either to be there all the time, or they can add it to be part of a smart stack. And a smart stack is a collection of multiple widgets that a user can put together, and depending on its relevance, the system decides which widget should be displayed when. So the purpose of a widget is that it should be something glanceable and provide the user with important information that they want from your app. So it's something that will be on their home screen most of the time. So it's something, it will be the most important information of your app and the thing that the user cares a lot about from your app. And by default, a widget opens to your app. So if a user taps their widget, it will open your app. But you can decide to customize that. So a certain widget might open a certain screen of your app. And that's something that you can decide for your widget. So some examples of widgets that I think are really glanceable and provide really great information is some of Apple's apps. For example, weather, which shows you the upcoming, the weather for the upcoming period. Or something like the fitness app, which shows you your activity rings and how far through your day you are. Or something like a calendar, which shows you upcoming appointments, or if you don't have anything, it shows you if you're free for the rest of the day. And I think widgets can be in be presented in different scenarios. So I think it's important to be aware that there will be different things that widget will show on different points in time. So for example, if the user decides to add your widget to their home screen, they will go through the sort of widget library. And here you can decide to display you decide what information you want to display here. So it's important to return the information that is the most likely for the user to see when they are having the widget on their home screen. So it's sort of like a preview for the user to see what the widget will actually look like once they have added it to their screen. The other scenario is, of course, when the user has added it to their screen. And this is something that shows user-specific data that is relevant at that point in time. And then another thing could be the scenario when there is no information to show to the user. So there will be like an empty state. So it's important to have some scenario to cover there as well, so that you can show something that is relevant or something that informs the user about why there's nothing shown in your widget. So with that, I want to go through how you can start creating a widget. So what you will do is to add a target to your app, a widget target, to your existing code base. And by default, Xcode will generate some structures for you. So these are all the structures and all the functions that you will need to start creating your widget. So it's all the minimum functionality that's needed for the widget to start working. So one thing that it adds is a provider. And the provider is providing all of the data that will be used to display the widget. And there are three different functions here. One is the placeholder, which is placeholder data. I will go through this in a bit more detail later. The other thing is get snapshot. And then we have the get timeline function as well. Get snapshot will return a single entry for your widget, whereas get timeline will return an array of entries for your widget. The other thing that's part of this class or this file that is created for you is a simple entry, which is the sort of timeline entry, and that's the data that is the data structure for your widget. And this data structure is used by the widgets view. So the widget extension entry view is what it's called by default. And this view is what the user will end up seeing. So it includes the entry, which is the data that will be displayed in this widget, and the body, which is the SwiftUI view that will be displayed to the user. And then we have the function, then we have the main structure. So this is the entry to the widget itself. So this is a widget extension, which provides the body for the widget and the widget itself. And then, of course, if you're familiar with SwiftUI, we also get this widget extension preview. And that is basically a way for you to be able to preview your widget as you work on it in Xcode. All right, I'm gonna go through these functions in a bit more detail. So let's start with getSnapshot. So getSnapshot is something that is called to get a single entry for the widget. So for example, this is displayed in the widget library when the users decide what widgets they want to add to their home screen. So if you have some information that you want to display that is specific to the user, you can return that information here. Or you can return a type of placeholder entry. So for example, if it takes too long to get the user specific information, you might need something like a network call, you can return a placeholder, some placeholder information instead, just so that you can display, just so that the system can display the widgets as quickly as possible and some great information as soon as possible. So the getTimeline function is something that is gonna be called consistently from the system as soon as the user has added a widget to their home screen. So this is where you return an array of entries that will be updated on the user's home screen. And then you can also return a policy of how often this function should be called by the system. So for example, you can say that you might want to call this function again as soon as it's done, showing all of the entries that you've returned in the previous timeline. Or you can say that you want to refresh it at a certain date, or you can say that you never want the system to call this function automatically. The next thing is the widget extension entry view. So this is your sort of entry to the widget itself. So this is where you will provide a system with your specific widget and the UI that you wanna display to the user. And this is sort of where it all comes together. So it's, you return the widget with the entries here, and this is where you lay out your you decide what view you want to return for the widget. Then another thing I want to touch on is that you can use something like Xcode Preview, which is super useful while you're working on widgets, especially if you have widgets with different states. So for example, if you look at this example screenshot, this is a widget that has support for both dark mode and light mode, and it looks slightly different. And then this widget also has a smaller version of the widget. So you can actually use Xcode Preview to provide preview context. So for example, you can say that you want to use the family system medium or system small to actually review. So if your app supports both a medium widget or even a large widget and a small widget, you can decide what you want to view in your preview, and that's really helpful while working on your preview. And another thing is that you can provide an environment, which you can pass in an environment and you can pass in a color scheme. So if you want to view it in dark mode, this is the perfect way of this is a perfect use case for Xcode Preview. So that is everything from me. I hope you enjoy this talk, and I hope you will start adding widgets to your apps. Super exciting. Thank you.
Thank you very much, Malin. And now over to Zach. If I can, there.
Cool, thanks, Carl. I will just share my screen and get underway. Alrighty. Can you see that okay, Carl?
Looks good.
Cool. Alrighty. So hey everyone, I'm Zach. I'm going to be talking about map memory management today. Talking specifically about MapKit maps, not any other kind of maps. And just a fair warning, this talk contains UIKit. We've had a lot of great talks recently on SwiftUI and all the cool things you can do with it, but this is not one of those ones. Before you say why not UIKit, before you say why not SwiftUI, wouldn't that solve all your problems? It actually wouldn't. I had a bit of a frustrating evening one time trying to replicate some of the stuff I need MKMapView for with SwiftUI and ran into its 1,000,001 limitations. You can read more about it in that blog post that I've got there. But that whole blog post kind of summarizes everything you can do with map in SwiftUI, and it's not a lot. So I don't expect that to be used in many production applications yet. But this talk is all about a memory management problem with MKMapView that I ran into. It's not so much a problem with the framework, it's just the way that things work that I ran into when building a map view for an iOS app, and just sort of walks through some of the steps I took to solve that problem. So hopefully a relevant example. It's definitely based on a real world problem, and hopefully we'll get something out of it. So the first step in this talk, you have an app with a tab bar, and one of those tabs contains a full screen MapKit view, something like this. It doesn't even necessarily have to be a tab bar, but the point behind the tab bar is more that the app is persisting that map view basically all the time. It's not hidden away in a screen that when it's dismissed, the map goes out of memory. So I ran into this problem when working on one of my apps, Petty, which is an app for finding fuel prices in New South Wales. And it has sort of three main tabs, and one of them is contains a full screen map view for finding petrol stations nearby. So that's the tab we're going to be focused on today. Like I mentioned, this is a somewhat common UI pattern. The tab bar with a full screen map isn't in and of itself super common, but the idea of an app that has a map view that's sort of always present is fairly common. But it can be problematic, and that's sort of what I was alluding to before. So I think for this particular problem, the best way to demonstrate is to show you. And so we're going to create a sample project, and we're going to get straight into Xcode and go from there. So just bear with me for a second while I set this up. So sorry. Alrighty, so here I have a completely fresh Xcode project. Nothing's been done to it. If you have a look here, we've got all the standard files you'd expect. I've even kept the storyboard. Nothing's been done. But I am just going to build and run this just so we get a baseline for what we're talking about. So we're going to observe the app's memory usage. Now, this is the complete app. It does absolutely nothing, and because we're in dark mode, there's a black background. We can see it's loaded. We started getting output there, and we can see in the memory debugger, we're using some memory. The app is doing something, who knows what. We're using 11.5 megs of memory, not much. I background the app, and it basically stays the same. So that's a completely empty application. Now I'm going to switch over to the starting point for this project. Alrighty, so I've made some very minor modifications to that same sample project, and I'll build and run to show you what's happening, but it's basically replicating the problem that I had in Petty. So this sample project has 3 tabs. Now it's running. The first 2 are completely empty, and the third one contains a map view. Now this is obviously a very simplistic map view. There's no annotations, no overlays, nothing drawn on it, but it is enough to demonstrate the problem. So if I go over here and look at the app's memory usage, just by loading that tab, we've gone up to like 55 megs of memory used. If I zoom in, scroll the map around a little bit, you can see that our memory usage skyrockets. And look, 116 megs, it's not ridiculous at this point, but it's kind of enough that you combine this with an app that has actual content in the first 2 tabs, and say a map that has annotations and pins and any other kind of overlay, and that memory usage can add up pretty fast. So if I background the app, you'll notice memory usage drops a little bit, but we're still kind of higher than we should be. We definitely don't drop down to sort of pre-panning the map levels or before opening the map tab down there. And our app sort of remaining at a high-ish memory usage. Again, I know that 88 is not a lot, but think about this in a real application with other things that need to persist. And yeah, that does get pretty large pretty fast. So the first thought that I had to solve this problem was to somehow respond to the application's lifecycle. So when the app, say, moves to the background, let's remove the map from the view hierarchy, and then just the same, add it back when the application returns from the background. So all of this, all of my work's going to be done inside of this map view controller. And sorry, I thought I'd change this, but I hadn't. So here we go. So now I'm presentation mode. So yeah, all the work that's going to be done is going to be inside this map view controller. As you can see, super simple for the moment. We lay out a map view, we set its default coordinates to Sydney, and we add it to the view as a subview. So what I'm going to do first is, instead of adding this once, I'm going to break this out into its own function. And that's a function we can call when we want to add the map. And then similarly, I'm going to have a remove map function. And all that that's going to do is remove the map view from the super view. And to be safe, before adding, I'm going to remove. And then what I'm going to do is just add some combine subscriptions to the application's state. So when we become active and when we enter the background, we're going to call those respective methods as you'd expect. So add map, and need to import combine. And cool. So pretty straightforward. Yeah, when we move the application to the background, we expect that, I guess, the map will be removed from the view hierarchy, and maybe this will result in less memory usage. So if I go over to the memory tab, before we load the map tab, we're up at 25, not too bad. Load the map tab, skyrocket to 55. Now I zoom in a little bit and we go even higher as we saw before. If I go back to the application home screen, sorry, to the springboard, you'll see we still stay high. There's no, it does come down a little bit, but there's no sort of noticeable difference. It's definitely not giving us the results that we want. And so we kind of need to think of another solution, because this isn't a good one. So looking at this, like, there's not a lot going on in here. There's not much really that could be using up all that memory. It must be the mapkit object. The MK map view, because like, what else could it be? Nothing else is happening. So what I'm going to do is I'm actually going to nil this object every time we remove the map from the super view. And I'll create it dynamically each time we need to present the map as well. So nil, remove from the super view. So then I'm going to add a new function down here. Don't worry too much about following along with the code as well. I'm going to post a link to like the proper thing on GitHub. I might stuff something up in this demo, so it's probably better to look at that one anyway. So generate map view, MK map. So we've got this helper function down here, which just when we need it, we can generate a new map view, the same one that we saw before. And what we're going to do is when we add the map, we're going to set the value of map view to a new map view. And we'll just guard before we add. Alrighty, so that should build. I'd expect that to build. So we just added the map to the view hierarchy. And now when I background I'll pull up the memory usage thingy. When I background the app, actually, let me zoom around a little bit so you can see the memory usage skyrocket up to 113 megs. I background the app. And that's pretty in line with what we want. We're down to 40 megs. Not perfect, but it's good enough. We're happy with that. If I open the app again, you see the map views are redrawn and our memory usage increases. We zoom around a little bit, memory usage goes up, kind of hit a stable point. Then when the app's backgrounded, exact same thing. Our memory usage comes right back down. And so it's working. We don't seem to have a leak. And we are reducing memory when the app goes into the background. And this is going to, a whole bunch more things, like our app gets more background time, and our app is more likely to get background app refreshes. And it's going to be faster when someone presses its home screen icon, because it doesn't have to go through that full launch cycle every time, because we're chewing too much memory. But if you noticed before, there were some problems with that. So for example, I open up the map view again, and suddenly we're back to Sydney. It didn't remember where I'd zoomed into. So if I sort of zoom into St. Ives here, go to the home screen and go back, we're redrawing the same map, and we're not keeping any of that map state, which isn't a great user experience, especially if somebody is using our app to quickly reference something on a map, checking something in Safari maybe, and then coming back. We don't want to reset them every time. That's not fair. So fortunately, there's a pretty good way to handle this. So what we're going to do, the map view itself has a property, it's probably a MK map camera property, and that kind of holds a lot of the metadata that we need to restore the map to its regular position. So things like the zoom level and the center point of the map are usually enough to, if we capture those and restore to those points, usually enough to restore the map to where the user last was. So it's quite handy. So what we're going to do is, before we remove the map from the subview, really all we need to do is capture the camera. So map camera equal to map.camera. But I have noticed some weird behavior where if you launch the app, and don't load the map tab, but then sort of you exit the app, this code will still run, and it's actually, the coordinates are set to 0, 0. So then you end up restoring to a state that is the middle of the ocean. Now, I have a really kind of hacky workaround. It works. It's simple. There's probably a better way, but all I'm going to do here is check that our coordinates are not 0 and 0, like latitude and longitude. Hopefully no one's looking for petrol stations in the middle of the ocean. So in the case of Petty, it's not going to affect anyone. Obviously, in your own app, you might want to handle that better, but that works for now. And so then, of course, what we want to do when we're adding the map is we want to check if we have sort of a cached camera position, and then we can call this set camera method on the map view, set it to the value of map camera, and that will restore the state of the map to where we last were. So if I build and run with these changes, and I go over to the map, and say I'll zoom in sort of Balmain way, close the app. Our memory usage has dropped again. You can see that here. So everything's working as we expect. When we open the map, there's a slight flicker, but we do restore the map to the point we're at. It's really, really good. Now, obviously, in a real app, you have other things to worry about, like map annotations or any paths or anything you've drawn. But again, keeping it simple here. So it does work. We restore the map to where we were. It's really good. But if I go to the home screen again, and I go into the app switcher, you'll notice we've actually lost the preview, because what we're doing is we're removing the map from the super view. And so when iOS goes to take a snapshot for the app switcher, it's got nothing to take a snapshot of. There's no view there. So we're going to solve this problem. This is going to be the last problem we solve tonight, because this is meant to be a lightning talk, but I'm already going a little bit over time. So what I'm going to do is find a new property up here on the view controller. Now, again, you could take this to an extreme and sort of persist this, but you could persist these like map cameras and the snapshot view between app launches if you wanted to, or you could even do all of this when someone changed tabs in the app if you wanted. Again, I'm just responding to like background and foreground stuff, just keeping it simple. So, and it is kind of expensive to redraw a map view, so I probably wouldn't be doing it like when the user switches tabs. That's a bit excessive. So what I'm going to do, and I'll just copy paste some code in here, is before removing the map, I'm going to take a snapshot. And really all this code is doing is taking a snapshot of the view, of the map view. And this is just a regular old UI view, which we can then add as a subview to our view. And we're just They're just some auto layout constraints, nothing fancy going on there. And then equally, we need to remove this from the super view when we add the real map back to the view hierarchy. Of course, we don't want our cached map view sort of sticking around. So if I go into this map, zoom around again, let's go to the airport, back around the app. At some point in there, iOS has taken a snapshot. You can see that our snapshot is remembered. When we go into the app, it does flicker, it does reload, but we do get back to that experience we expect and seeing the part of the map that the user was last on, all while keeping our memory usage low when we're in the background for all of the benefits that I spoke about before. So that's all that I've got for live code. I'll just flick back to Keynote for a couple of closing slides, and then that'll be it. Alrighty, so what did we cover? Well, we observed the problem of high memory usage of an MK map view when the app is in a background. And this is because as you scroll around while you're using the app, the MK map view object is caching a lot of the points and the map data that you come across, but it's not releasing them itself. So we attempted to fix the bug by hiding the map when the app moves to the background. That's just a UI fix. It didn't actually solve our memory usage problems. And so finally, our actual solution was to destroy the reference to the MK map view object. And that acts as a bit of cleanup as well, removing some of that cache from our memory. So it could be advantageous there if you just think it's good practice to clear out the map view stuff. We've restored the map to the last known visible area. This is important for that user experience. It would be pretty annoying if the map sort of always defaulted to, say, the user's location or a central location instead of where they were last looking at, especially if that point they were last looking at it was only a few seconds earlier. And then finally, we created a placeholder overlay view so that something is shown when we move to the app switcher. And this, again, just helps with the experience overall when you're using the app. It sort of removes, it reduces, it makes it less obvious, that something funky is going on when the user moves away from the app. So where to from here? This was very brief, but there's a lot more you could do with this if you were using this in a production application. So obviously there's more considerations like adding and removing annotations or overlays to the map. Most maps in apps have funky overlays or things going on. They contribute to memory usage, but they also need to be considered how to efficiently add them back when you need to do that, because it can get expensive to redraw all of those all the time. Another consideration might be restoring user interactions. So if a map pin is selected or an annotation is visible, you might want to restore this too, or maybe you decide not to remove the map view if the user is in the middle of something when they close the app. That's also an option. Different snapshots for light and dark mode. That's a big one and something I didn't cover, but at the moment, if the app took a snapshot with that snapshot view that I'd replaced the map with, and the phone changed from dark to light mode, for example, that snapshot would still be shown in dark mode because it's simply just a UI view at a single sort of point in time. That snapshot isn't updated. So that's another consideration. And finally, better transitions between the snapshot and the normal state. So as you could see in my map, it flickered a little bit. You could probably do that a bit nicer, maybe add a bit of a delay and a fade or something, just so that you don't kind of see the map redrawing, but that's all minor stuff, low hanging fruit. So that's all I've got. All of the code from this talk is available on GitHub, very similar to what I went through tonight, but just a bit more polished. And if you've got any questions, you can tweet at me, or I'll be around the Sydney CocoaHeads Slack tonight or in the Zoom call after the meetup if you want to discuss anything. So thank you, and I'm going to hand it back to Carl for David's talk.
Thank you, Zach, and we will jump straight into it.
G'day everyone, I'm David Reedy. Welcome to Show Me, Don't Tell Me, a look at adding user guidance to a SwiftUI application. This presentation was developed and recorded on the lands of the Darug and Gundungurra people. For tens of thousands of years, they have been the custodians of this place. I pay my respects to their elders, both past and present. In this presentation, I'm going to be talking about mainly business software. The software I'm currently working on, which is designed to be used in an aged care setting. So things are slightly different, I suppose, if you're designing software for leisure. So if you're writing a game or something, but in this case, I'm going to stick to software that people have to use for some reason other than they just want to. So, work is making them use the software. Software can be confusing. Now, we know that in theory, everything in our software will be completely obvious. It certainly is to us when we're designing it, and of course it should be to everybody else. Basically, we assume that any user of our software will think in exactly the same way as we did or our designer did when we designed the software, that it makes logical sense to us, and of course, therefore, it will make logical sense to whoever else happens to be using our software. That's the theory, though. In practice, we know it's slightly different. Interpreting an interface can be difficult, especially as quite often we're trying to balance up having enough information on the screen for our app to be useful and balancing that against putting like hints or labels or whatever to help the user use it. And so there's a balance there, and we may go too far one way, we may go too top right to bottom left. But the order of steps of doing something may not be as clear to the user of a piece of software. I remember the very first piece of software that I put out to the, in inverted commas, general public was a point of sale system. And the first testing was done in the shop that I was running at the time. So I had thought, of course, that if I'm going to make a sale, I'll identify the customer, put in what they want to buy, have them pay, print out a receipt, and it's all very straightforward. My business partner, and in fact most of the shop staff, were able to come up with many, many different ways of doing that didn't start and work through in a logical manner. I therefore became much better at not having a modal system in most of the screens. So sometimes the order in which things happen is not quite as clear to a user as it is to us. When we're talking about business software, often efficiency is important, and the most efficient method is not necessarily clear to the user either. And so again, we might want to give them some hints about what's the best way to go about doing this. There are other considerations as well when it comes to what goes into our software. Like anything else, you only get one chance to make a good first impression. And so when someone is picking up our software, even though in the case of business software, they may not have a choice about whether or not they use it, we would still like them to get a positive first experience with our software. We would like them to use the software and come away feeling empowered rather than confused. Often we've got great features that may not be immediately obvious to a first-time user, and we would like our users to know about them. We'd like them to know that they can do all sorts of interesting things that will make their work better or whatever that we're writing the software for. And so we'd like to tell them about that. And in many cases, we'd like to let the users play with the software. If you're going to be working with business software, one of the concerns, of course, is that you're going to do something that will muck up the business's data. So it would be really nice to have some way that a user can experiment with the piece of software without actually causing problems for the business. And finally, there's one more thing, that Apple have a rule about apps needing to do something to be approved. Lots of business applications require accounts or other things happening, especially if they're going to go onto the App Store. And it may not be obvious that anything can get done without having an account that has been set up some other way. In the App Store review guidelines, it says this, that if your app is not particularly useful, unique, or app-like, it doesn't belong in the App Store. Well, the first App Store application I wrote was for school teachers. It was not particularly useful unless you were working in a school as a teacher and the school had set up the back-end system that you needed to use it. But what I put into that was a demonstration system so that you could play around with being a teacher and taking the role with a whole lot of fictitious data, and never had a problem with getting that approved in the App Store. So I don't know how strict they are about this, but having something that you can show to people and demonstrate your application without having to have a whole lot of stuff set up in the background certainly makes it nice for when someone says to you, well, show us your app. It means you can show them some of the functionality without having to have something set up in the background. So we're going to look at two different approaches to this. The first one is a guided tour, a way of showing potential or new users of your software a little bit about how the software works. Basically, its purpose is to explain the features, not necessarily teach someone how to use them, but to make them aware of what the features are. And we don't want to bore them, so we need to put in there some way that when they go through the tour, if they go away and do something else and then come back, they don't have to repeat the stuff they've seen before. So they're the two main things that I was looking at when I put the tour together. The other one is a training mode, and we'll come back to that one later. There's a little bit more to that one. Now, this is a SwiftUI app, so obviously I wanted to be able to implement this with SwiftUI. And SwiftUI turns out, especially if you're doing user interface stuff, to be pretty good for doing inventive things. One of the nice bits is because of the way SwiftUI is done, that most of this can be added with very little modification of existing code. In many cases, your SwiftUI code stays pretty much intact. You might need to add a few lines to it, but generally don't take anything away. And it is very easy to use the architecture of SwiftUI to let you manipulate things in the background very easily. In fact, you can separate this out so that there is no reason why a different developer or a content specialist with a little bit of help wouldn't be able to put this in place after the main functionality has been written. So let's have a look at the tour functionality. When you first start up the app, after it's just been installed, you get a choice of going into tour mode, training mode, or to use the application for real. And at the moment, we're still in testing, so we've got the developer bit down the bottom. Let's have a look at tour mode. There are three ways you can be interacting with UCare at this stage: as a family member, as a staff member at a facility, or the soon-to-be installed home care package system. Let's have a look at facilities. Again, facilities have three different levels of staff: the normal care worker, the manager, and medical specialists who are visiting. Let's look at the facility manager. To begin with, there's a bit of an introduction to what's happening. All of this is just standard SwiftUI so far. When we hit get started, we go to the today screen, which is one of the screens that you would normally be using in the app. We have an overlay that tells you a little bit about the screen and the sort of things that you're going to be doing on it. When you hit continue, that disappears. You now have the screen in the background. It's full of dummy data so that you can now interact with the program without a fear of destroying any real data. As you go on, as you go to a new screen, you'll get a new pop-up telling you what's going on. Again, we can continue. We might go across to the next one, photos. If we want to get rid of this, we can just hit the top button as well. That will, again, make it disappear. If we now go back to pages that we've been to before, we don't get a pop-up telling us things we've already seen. But if we go to a new page, we do get a pop-up, and so on. As every time we see a new screen, we get a new pop-up until we turn demonstration mode off. To turn demonstration mode off, we have a setting in the settings view that basically lets you leave the tour mode. So let's start having a look at some of the code. One of the first things we're going to need is some way of holding on to information about whether or not we're in training or tour mode. And to do that, I have a small object called overlay settings. Because it's a SwiftUI and we're going to want to use it throughout our code, we need to make it an observable object. That's one of the reasons why it's a class rather than a struct. We need to have a Boolean to know if we are in tour mode. We have another Boolean to let us know if we're in training mode. And there's a third Boolean, which we'll get back to. It's there for a reason. We'll see that in a little bit. And of course, we need to have an initializer. So to persist the tour and the training modes, I have a settings object that persists stuff out to permanent storage when the app is not running. And so we load in from the settings object, whether we're in tour or training mode. And it doesn't actually matter what we did change to at this stage, but we'll just set it to false because you got to set it to something. Over in app.swift, we're going to have to add in our environmental object. So we'll make a settings object using the overlay settings that we had before, and then add that in as an environment object. Splash view is just the splash screen that is the first thing that pops up. So we just attach it to that. We've got to put it in somewhere before we use it. and may as well be on the first screen in the app. We need another helper object if we're going to fulfill the requirement that we don't repeat things. So I have a simple struct called tool coordinator, and this is going to help us make sure that we only show each screen once as we go through. It's really simple. Basically, we have an array of strings that's going to hold the names of the screens that have been presented. We're going to have a function called shouldShow, and shouldShow basically will return true if a screen should be shown and false if it shouldn't be shown. And all we do is see if the don't show list contains the name of the screen that we're interested in. We have a hasShown function, which is how we add the name of a screen in once it's been shown. All we then need is a reset so that you can reset it. All that needs to do is to dump everything out. So we've got a very simple structure here that can keep track of what has been shown. Of course, we use a very similar thing for the training coordinator to do the same thing for whether a training screen should be seen again. So let's see how all this goes together. We're going to have a look at the visitor record view, which is the screen that we had a look at in the demonstration. Basically, everything that appears is part of this VStack, which we've enclosed inside a ZStack. I'm just going to close that up. We're not really interested in that at this stage. But part of the ZStack is this group section down here. Basically, that's what decides whether or not the tool coordinator or the training coordinator should be shown. We check the environment object, and if the tour is shown and the tool coordinator object says that this particular screen should be displayed, then it will be displayed. And similarly for the training screen, as you can see down below. Because we're using a ZStack, whatever is in these things is going to be overlaid on the contents of that VStack, which is showing most of the things. So let's have a look at what happens down there. So we have a tour view, and this is the code that is going to provide what appears on the tour. You can see that it's fairly straightforward. A lot of this is cosmetic to make it look nice, but basically a screen has a title, it has the body of the text, a continue button, and that's about it, really. When the continue button is tapped, then we let the tool coordinator, our static object, know that this screen has been shown. That's going to add that into that list so it doesn't get shown again. And because tool coordinator is not an environment object or any other sort of Swift object, we then just toggle the overlay settings did change. That will cause the screen to redraw, which means in this case that it's going to check, should this display be shown? The answer will now be no, because we've added it to the don't show list, and so the screen will refresh without the overlay on it. Seems to be the simplest way of doing it. Having looked down further, you can see that realistically everything down here is just to make it look pretty, give it nice rounded corners. We set the opacity to about 80%. That seems to be good enough that everything in front is clearly readable, but what's sitting behind is a little bit faded down. We also put a white overlay over the main part of the screen again, just to increase that contrast so it's easier to see. But that's pretty much all there is to it. Design the tour overlay, pop it in here, set up your variables, let the tour coordinator know that things have happened, and then force a redraw. Before we look at how the training mode works, let's have a quick look at the way the panels work. For training mode, panels can appear in different places because we don't want them to cover information on the screen. So we want them to be able to sit at the top and the bottom or in the middle. So let's just have a quick look at how the panels work. This panel's in the middle. This one's up the top. This one's down the bottom. As you can see, the different buttons appear as appropriate for whether the first step, the second step, the third step, or in this case, the last step. As you can see, the done button appears automatically. Okay, so let's have a look at what happens when you're in training mode. Again, you pick which sort you want. Let's have a look at carer training this time. I've cut this list down because it is in fact quite long. I'm actually trying to think of a better way of doing this, but at the moment it just lists everything. Let's have a look at how we would record visitors. Again, we use this pop-up system where information sits over the front. In this case, they can appear in 3 different spots, as you'll see throughout. Quick introduction. The lower right corner allows you to advance. It tells you what needs to be done next. You can either do it yourself if you wish, or by tapping the Show Me button, the application will do it for you to show you what should be going in there. Again, tap to go on. Show Me will do this again. Notice that all the interactions are animated, so it sort of draws your attention to it. Some things which are very complex and which are taught elsewhere skipped over, so we just put a photograph straight in. And then we've got the finish up. Again, the top left-hand corner will allow you to dismiss the training as it's going on, and the bottom left-hand corner lets you go back a step. Hit done, and we're done. There's how to use the visitor report. Once you're here, you can interact again with the application yourself. Hitting send out does not, in fact, send the message. It actually sends it back to this device. So you can see what it would have gone to relatives without disturbing the imaginary relatives of the people with the imaginary data or of the. When it comes to doing the training view, it's a little bit more complicated, only because it's doing much nicer things on the screen. There is an integer defined up the top called training progress, which just holds which step of the training we're at. So it starts at 0 and counts up. I won't bother scrolling up to show you that. We define an array of strings called training text. This is the text that will appear in each of the training overlays as they appear in the program. They can be single quoted strings or they can be triple quoted strings. One of the improvements I might make is to turn these into attributed strings so that they can have some bold or italics and other formatting in them. But at the moment, these are just straight strings. There are, in this case, 6 overlays, so there are 6 strings. The training view itself is just a VStack, and the VStack has got a number of bits to it. It's got a spacer at the top, possibly. It's then got the section that's going to show us the information that needs to be displayed and the buttons and things like that. And then below that there is possibly another spacer to space it up. The way we adjust where the text appears on the screen is by either including or not including the spaces. So given that we have the training progress, knowing which step we're at, if we want a spacer at the top, we just check to see that on screens, in fact, in this case, on all screens, there is a spacer at the top. So we just check that the screens that we want to have a spacer at the top here, and then put the spacer in. We use an animation so that we get the nice movement on the screen rather than it just appearing. We then have the VStack, which contains the contents. We will come back to that. And we finish with the spacer at the bottom. These are the screens that require a bottom spacer. So if there's a top and a bottom spacer, it means that the information is going to appear in the middle of the screen. If there's just a top, then it will appear down the bottom. And if there's just a bottom, it will appear up the top. So it's a bit in reverse. It's very simple to get the hang of once you've done it like the first time, really. So the contents though then go into the VStack, which realistically is just the buttons, the title, and the text. And that's what's being set up here. So this is our top left button. Basically, it's using the little system icon, which is the cross inside a box called clear. If you click on it, we turn the training mode off in our environment object. And then again, to get the screen to redraw effectively, we do a did change toggle, and that will cause it to redraw. For some reason, just setting it to false doesn't always do it. We then have the headline, and to center the headline, all I do is pop another button on the other side that has no action and is invisible, but it centers the headline. Otherwise, because of the first button, the headline gets pushed a little bit to the right and it just doesn't look nice. So put a dummy button in. Notice I use the same system image. So these will always be the same size. So consequently, the thing should always be in the middle. Then we pop in the text, which is, what we need there. Under that goes the buttons that we want. If we're on the very first one, we don't have a back button. Otherwise, this puts the back button in. If there is a demonstration to happen, we put the Show Me button in. Again, we just do that by selecting which of these screens has a Show Me button, put that there, pop the button in. And then similarly, for the button on the bottom right, basically, if we're not on the last one, we just put the button in. If we are on the last one, we put the done button in. And that gives us sort of the nice layout, and pretty much just by knowing what step we're on in the training, we're turning on and off automatically the bits that we need on that screen and adjusting its position. So as you can see down the bottom here, there's that spacer. We do everything with animations. Animation duration is just a constant to save magic numbers. I use 0.3 of a second. It seems to work nicely. It's not so long that it gets annoying that everything is animating, but it's not so short that things are jumping abruptly. So that's pretty much all there is to displaying the information. The next thing, though, is to handle the show me. So that is done with another function called doStep. Now, this one can get slightly complicated because it has to handle each of the steps, but basically a switch statement on which step number we're on and then what needs to be done. I'll come back to this one just in a sec. But basically by adjusting the values of the bindings, we can get things to happen on the screen quite nicely. So just as if the user had adjusted it, we can adjust it in our code. So for example, where we want to show that the resident has enjoyed their visit, we simply set this. It will animate for us automatically. Down here is the one where we put the image in. In this case, we have different pictures. If the randomly selected resident is male, we use one photo. If the randomly selected visitor is female, we use a different photo. We don't use different photos for every resident. Every man looks the same. Every woman looks the same. It works quite nicely. And one of the things that happens in the background, which we need to handle because we're not doing it using the camera, is we need to hide the photo button. So we just do that again by adjusting the binding that's in the normal part of the screen. The other interesting one, though, is this one with visitor names. Basically, all we want to do is put in a visitor name, basically saying either his daughter and her husband, or her daughter and her husband, or their daughter and her husband, depending upon the preference of the resident. But if we just paste the text in, one, it's very abrupt, and two, it's easy to miss that it even went in. One of the things I wanted to do was to slowly animate in the text so it looks like it is being typed. And that's what this little bit here does. Now, there may well be a better way of doing this, but I fiddled around for a day and I couldn't come up with one that was reliable and always worked the way I wanted it to. So I've gone back to being very basic, and at the moment this just works. Basically, there is a new string, which is whatever it is that we want to show. And then we loop through it and basically put a 1/10 of a second delay between each one, and we simply add each. We adjust the binding. We adjust the contents of the binding so that it has the first character, then the first 2 characters, then the first 3 characters, and so on until it has typed the whole string in. I think that looks much nicer than it just being pasted in. So that's what this bit of the code is doing, and I feel it does make that look better. So pretty much that's all there is to it. Using our step count, we can adjust the position of the overlay on the screen, and we can adjust what's going on each of those, which buttons are there, and we can control what they do. Now, I'm imagining this could get very, very complex, but in our application, there are no segments which take more than 5 or 6 steps. So for UCare, it looks like this will work, at least as a first approximation for training. There is a third mode we will probably put in, but that will involve written materials and like more of a workbook approach. And again, it will be built on the back of this. It seems to work quite nicely. So that's pretty much it. At least that's where we're up to at the moment. We really want a good introduction and training system to go with UCare, so we've still got more to do. The 2 main things that we're going to work on next is we're going to add some video inserts. So to both the demonstration and the training sections, it's pretty simple to add a video player into those overlays and then record and do some training videos that go into there. And then finally, we want to have a much more formalized induction systems that will involve a workbook and training exercises, which can be marked inside the app. That's a much bigger job. So I've been putting that off. We probably won't get to that until the new year. But that's where we're up to at the moment. If you'd like to contact me, then I'm at ReeDD on Twitter. That's my email, david at utea.ch. And of course, our website is over at www.uca.re. So I hope that's been helpful, and I look forward to lots more applications, including tutorials and trainings built in. Thanks very much. Bye.
Thank you very much, Josh, Malin, Zach, and David. That was a big night. And good night, everybody, from Sydney CocoaHeads. We'll talk to you in the Slack.